Let's look at the energy level n is equal to 2. Possible L values are 0 and 1 as we discussed. For L is equal to 0, ML is equal to 0. For L is equal to 1, ML will be equal to -1, 0 and +1. For every value of ML, there are 2 electrons, ms plus 1 by 2 and ms minus 1 by 2. So there would be 8 electrons. There would be 8 electrons found in the principal energy level n is equal to 2, and they would have the following designations. These are the designations. You can see electron number 1, n is equal to 2. I am not talking about K shell, I am talking about L shell. N is equal to 2. L value 0, ML value 0 plus 1 by 2. Electron number 2, N value 2, L value 0, ML value 0 and MS value -1 by 2. Third electron, N value is the same 2. L will be equal to now 1, ML -1, MS plus 1 by 2. The same values, but MS is equal to -1 by 2. Again, for fifth electron, N is equal to 2. We will write L, your L value is equal to 1, ML is equal to 0, MS plus 1 by 2, L is equal to 1, 0, -1 by 2, and 2, L is equal to 1, plus 1, plus 1, plus 1 by 2, -1 by 2. So these 8 electrons complete the state with n is equal to 2, and which is the L shell of the atom. L shell में हमेशा के लिए 8 इलेक्ट्रॉन आ सकते हैं, and the formula for finding the electron is, you know, number of electrons will be equal to n is equal to 2n square. In this case, n is equal to 2, so 2 multiplied by square of 2, it will be equal to 8 electrons. So there can be only 8 electrons, and every electron has its own set of 4 quantum numbers. You can see, किसी इलेक्ट्रॉन का भी क्वांटम नंबर एक दूसरे के साथ कोइंसाइड, सेट एक दूसरे के साथ कोइंसाइड नहीं करेगा, सिमिलर नहीं होगा. There will be 8 set of 4 different quantum numbers. So in this way, I can write the quantum number of any atom, electron present in the atom, in the periodic table. So these are the quantum numbers which we can describe for different electrons in an atom, and you can see that there is a principle which we call as Pauli exclusion principle, and according to that principle, no 2 electron in an atom can have the same set of 4 quantum numbers. हर इलेक्ट्रॉन के अपना set of quantum number होगा, and that is clear from this that there are 8 different sets and there are 8 electrons in the shell. So I will say every electron has its own set of 4 quantum numbers. Now these quantum numbers, if you write these 4 quantum numbers on the envelope, then the letter will be received by the specific electron in an atom. For example, when I write 2, 0, 0, plus 1 by 2. So what does it mean? This is your L shell. L shell में ये आपके पास K shell है, ये L shell है. L shell में एक इलेक्ट्रॉन ऐसा है जिसके ये 4 क्वांटम नंबर हैं, तो ये लेटर सिर्फ उसी इलेक्ट्रॉन को जाकर मिलेगा. अगर आप इसके साथ 2, 0, 0, -1 by 2 लिखें, तो इस शेल में जो दूसरा इलेक्ट्रॉन है इस s ऑर्बिटल में, उसको जाकर ये लेटर मिलेगा. एंड सिमिलरली फिर P में और फिर अगर P और D में अगर D एग्जिस्ट करता है तो उसमें जाकर ये मिलेगा. सो दिस इज हाउ वी कैन find different quantum numbers. Now this is what we have earlier discussed. Primary energy levels, shells are defined by L. Energy sublevels are defined by primary energy levels are defined by N, which we call as shell. I already defined K shell N is equal to 1, L shell N is equal to 2, and so on. And energy sublevels, we call them subshells. Orbitals are named as a combination of N and L. For example, an electron may exist in 2p orbital. So for this, N is equal to 2 and L is equal to 1. Shapes of these orbitals will be discussed soon. And this is your energy level. 1 s orbital, 2 electrons, 3 p orbital, 6 electrons, 5 d orbital, 10 electrons, and 7 f orbitals, 14 electrons. So every orbital contains 2 electrons. So you can see here is 1 orbital, number of electron 2, 3 orbital, number of electrons this, 5 orbital, number of electron 10, 7 orbital, number of electron 14. And this is how we can write L is equal to 0, 1s, okay. L is equal 2s, also L is equal to 0, but in this second shell I have L value as 3 electrons with this, with 1, 2, 3 orbitals in this. 3s, L is equal to 0, and you can see 3d, 1, 2, 3, 4, 5. 5 2s are 10. And similarly 4d and 5d and then f orbitals. So these are the quantum numbers, and these are your increasing energy. Lowest energy, second higher value of energy, still second higher value of energy, still second higher value of energy, so on, so on. And you can see here that 2s is lower in energy as compared to 2p, and this is determined when I applied the magnetic field. Now there is a very famous principle by using which we can write the electronic configuration of an element. So you can see here I write like this. I write horizontal lines. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, and so on. And then I draw arrow. First it will be filled, 1s2, then this will be filled, 2s2, then 2p6, 3s2, then 3p6, 4s2, and then 3d10, 4p6, and 5s2, and similarly this one, this one, this one. So in this way we can write the energy configuration or electronic configuration of an element. In this case what I will write 1s2, and then I will write 2s2, and then I will write 2p6, and then I will write 3s2, 3p6, and then 3d10, and then I will write 4s2, s2, and sorry, this 3d10 will come later. 3p6, 4s2, then 3d come. This is 4s2 and then 3d10. So first this level will be filled, then this one, 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 you can see the third orbital, d orbital of the third shell, is filled after 4s. And similarly, you can write for it. And this was described by Afubau, and it is called as Afubau principle for designating the electronic configuration of different elements. You can see here it is vanadium with atomic number 23. With atomic number 23. So what you can write? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. 10 अभी complete नहीं हो सकता है because the number of electron is 23. So I will write 3d3. 3 orbitals are occupying the electron, where remaining 2 are empty. This can also be written in this way: 4s1 and 3d4. 4s1 and 3d4. And that's why we call it as the transition metal, because transition of the electron can take place between s and d orbital. The last one I can write as 4s1 and 3d4. This shell is not complete, and this orbital is also not complete. Subshell is also not complete. So ये आपके पास transition metals हैं. If you see in the periodic table, these are the transition metals: 3d, 4d, 5d, 6d. These are transition metals. And similarly, these are also transition metals, F transition metals. Okay? Now, this is your S, 1, 2, 3, 4, 5, P, 2, 3, 4, 5, 6, and then D, and then F. We are coming like this. So this is the way how we can fill electron in an atom on the basis of its increasing energy. Okay. Let's go.